This session is about getting started with serverless and serverless databases. A little bit about me. I'm Zachariah Noel, popularly known as Zach Jones Noel. Uh, I'm a cloud architect for serverless at Mobility Solutions and Services Private Limited, Bengaluru, India. I'm a AWS community builder, and I love to brainstorm about serverless. Feel free to connect to me over LinkedIn or Twitter if you have any questions or queries about serverless. Today, in this session, we will be looking into serverless. We'll see why to adopt serverless and also the different AWS serverless offerings that is there. We'll be getting started with serverless databases, a quick introduction to Aurora Serverless and DynamoDB Serverless, with the demo of creating tables on Aurora and DynamoDB. So looking into serverless, the common thing that comes into the mind is serverless is about uh, enabling or promoting cloud computing execution model where the developers are focusing on the business logic or the code itself instead of worrying about the infrastructure or provisioning different virtual machines or enabling servers, installing different packages and everything, where they don't have to worry about these things, and instead they can focus on the code and just build the complete application logic and deploy them over the cloud. Uh, the serverless computing encourages event-driven architectures and microservices because serverless itself is very decoupled, and whenever there's a communication between different services or different models of microservices, what happens in the background is, for example, there is a Lambda function that's speaking to another Lambda function, or the Lambda function is speaking to a different AWS service like DynamoDB, or it is speaking to another application integration service like step functions or other services where the data, the processing happens elsewhere and the data is returned back as a response. So the serverless world, it goes with a very microservice based architecture with computing with event-driven architectures and microservices being a friend in the architectural patterns. As there's a common myth that serverless is no servers, but in fact, you're not worrying about the servers, but in reality, there is a server sitting somewhere, and the whole application is running on a server. But just that you are not physically going and provisioning it. Instead, there's the cloud provider like AWS who is providing the infrastructure to you so that your application runs over it. With serverless, the code deployment is much faster because you're not worrying about how to do things. Instead of worrying about how to do things, you're thinking about how to deploy things, how to build things and get it on the cloud. So your deployment process is much faster when it's compared with the traditional computing architectures. And also, as in the serverless world, the computation happens near to the end user, with all services like CloudFront, where the Lambda function is running at the edge location. There's a reduced latency there, making it much faster for the end users to see the results. Why adopt serverless? So in the serverless world, the best thing about serverless is you're only paying for what you use, and you're not paying for something that's already provisioned and it's idle for a while. When it's compared to a server-based architecture, you're deploying the server and you're paying for the time it is idle. Instead, in the serverless world, you're only paying for what you use and when you use and how long you use. In serverless, like I was mentioning, the focus is more on the business logic side, rather than the infrastructure itself. With serverless, the cloud providers itself have the shared responsibility model, so ensuring The scalability of the application is much better with the scaling up and scaling down based on the traffic spikes is handled smoothly. Also, the applications are made highly available with deploying them over multiple AZs. A se- with serverless, the integration with other services also other AWS services is also very smooth. So all you have to do is you would have to import the SDK and start using them. So it's that simple. And also there are different triggers for different AWS services. Like for example, DynamoDB. With DynamoDB streams, you can invoke a Lambda function, or SNS, you can invoke a specific Lambda function. The ease of integration between the AWS services is much better. So with serverless, you have an added advantage of making things decoupled and at the same time ensuring that everything is connected. With serverless, the whole concept of ensuring a less carbon footprint of your application is achieved because the cloud provider itself is interesting and ensuring that the application is less less has less carbon footprint in the world, because it's only running only on the time of demand and when there's a request. So your application is much greener in that context. The different AWS services uh, in the serverless category are: for the compute, we have AWS Lambda function, there's Fargate, which is a container-based serverless offering. Storage and databases, we have uh, S3 for all the object-based or media files, or storage for storing a large amount of data up to 5 TB. And databases, there's DynamoDB and Aurora Serverless. With serverless, the application integration happens smoothly, like I was mentioning. So the different AWS services which enable these are AppSync, API gateways, step functions, Event Bridge. There is a lot, and then there's a lot of other services which enables serverless. Like there's CloudFront, there's CloudFormation, I Cognito for all the identity management, Amplify, which is the uh, front end web and mobile serverless offering, which enables a smooth integration and creating and deploying serverless application, a full stack serverless application into the cloud. So coming to the different AWS serverless databases, the two serverless databases what AWS provides in the serverless wing is DynamoDB and Aurora Serverless. So DynamoDB is from the NoSQL world, where the key value pair is being stored as the record of key value pair or documents is stored in the database. This is primarily used in game tech, e-commerce, and since it's highly scalable, it's also used in places where there's a huge traffic spike, and the performance is amazing with DynamoDB. Aurora Serverless is the traditional and relational database where systems built using relational databases such as banking or CRMs adopt it, where uh, this supports also Postgre and MySQL. So about more about Amazon DynamoDB. It's a fully managed NoSQL database. The scalability is much better with DynamoDB because it's again a fully managed service which is being handled by the cloud provider itself. The You have an option of choosing your own capacity, where you're provisioning a minimum and a maximum range, and also you could go the on demand. So in case you don't know how your traffic spikes are, or how are the access patterns are going to be in terms of uh, uh, so how well so based on the traffic spikes, the capacity or the provisioned capacity scales up and scales down. And with on demand, you would have to worry about all these things and let the cloud provider decide for you. The Delivery of DynamoDB is to a single digit millisecond performance because this is highly available, and also it's deployed in multiple AZs. And with the global tables, you can access it from any given region at a very fast rate. So DynamoDB, in terms of the performance, is very high, and uh, even Amazon with traffic spikes with uh, Amazon during the traffic spikes during the Thanksgiving or the holiday seasons, uh, the DynamoDB is scaling much better and much faster as the performance. DynamoDB also uses pay-per-user pricing, so it's based on your access patterns is what you would be paying for, and the different queries or different interaction with DynamoDB happens over SDK APIs, where you can scan or query to get fetch data from DynamoDB tables. For SQL based users or developers, there's also a provision of PartQL, which enables users to retrieve data just with the SQL command. So you could select stuff from table and you could get it, even though this is a NoSQL based table. You could use PartQL to have SQL based queries and fetch data. The ease of working with global tables and syncing the global tables is much easier and much better with DynamoDB because in the background, under the hood, it's all placed in different hashes, and the global tables sync very well. So let us look into the DynamoDB. So on the console, once you go to the DynamoDB AWS console, you could create a new table, and we'll give it a demo name, demo1. So whenever you're going with the partition key and sort key, you would have to think of it because these will be created only once, and based on your access patterns, you only have partition key, or you could have a combination of partition and sort key, which makes it a unique record. And you can have different data types for the sort and the partition key. In terms of, if we go with the customized settings, there are different classes available. So DynamoDB also provides a standard class and a standard IA class, which is infrequent access. So in case if you have a table which has less frequently being queried upon, you could use with standard IA, which makes the cost of all the APIs up to 60% less. So it helps you a lot on the cost saving side. When you're deciding about the read-write capacity, you could go with either on-demand or provision. If you choose, if you're familiar with how your traffic is going to be, provision would be the way where you could say the minimum capacity and the maximum capacity, and also you could even identify the target utilization about it. But if you do not know your traffic spice, you can even go with the on-demand, where it scales automatically based on the traffic. With DynamoDB, you can even create different indexes. So you could create a local index, or you could create a global index, where you could create secondary indexes with local index. So say you could create a sort key with SDA, and it creates an index where you could identify if, when you're using this specific index, you could either get all the keys or specific keys, or you could include only, or you could so you could include only a specific attribute, or you could specify only the keys itself with the values, or everything. So whenever coming to the encryption or the ensuring that the data is secure, DynamoDB is defaultly it's encrypted at rest, and that is the option that you're seeing owned by Amazon DynamoDB. But if you have your own managed key, you can even select that, or you could even have your KMS key that's available, and you could choose that for encryption. So once you create the table, it says creating. So once the DynamoDB table is created, you could even see the overview of the DynamoDB table, where you could see the different configurations that this specific table has. You can know what the table class is, if it has any indexes, how many global and local indexes, if DynamoDB stream is enabled or not, or if point in time recovery is enabled, time to live is enabled or not. And CloudWatch provides us with different capacity metrics based on the different read and write patterns. So you could even explore the table items from the console. Since this is a newly created table, there is no data and it would not have any items. But if you wish to create an item from the console, you could create with providing the partition key that was defined. And as a JSON object, you could be able to create a specific record on DynamoDB. And you can, from the console, you could even do different operations like scan or query, and based on which you can even have different filters and run it from the AWS console. So heading next into Aurora Serverless, Amazon Aurora Serverless is a fully managed relational database. The Aurora supports MySQL and PostgreSQL. It also works on pay-per-user pricing model. With uh, with Aurora Serverless, although you are provisioning for a under the hood server, but the interaction is happening over data API, which makes HTTP requests to the database that's there, and all your queries work on top of the data API, and all the pricing is based upon the data API usage. So with data API, from the traditional world of RDS or having your own database on EC2 or anything such, you would have to ensure that there's a TCP connection that's persistent. But with data API, you wouldn't have to worry because everything is working on top of a HTTP request. So let us look into the Aurora Serverless table creation. So once we head into to create a Aurora Serverless table, you would have to head into RDS. In RDS, you would have to create a new database. So let's get into database and create a new database. So RDS facilitates with creating Amazon Aurora or MySQL and Postgre, all of it, which is a server-based offering. But once we select Aurora, and you could even select the different offering from Aurora if it's either MySQL or Postgre. So we'll go with MySQL. With capacity, if you go with the provisioned, this is creating a server-based database. Instead, in this demo, we focused on the serverless. So we'll go with serverless, and here we can select which version of MySQL Aurora we could use. So let's go with 5.6. Here you'll be creating a new database cluster, and also to connect into the database, you would have to create a admin user who has access to these things. So say admin. Okay, so you could either create a new password, or you could even uh, choose a auto-generated password. So you could go with auto-generated password. Once you're creating the capacity, what you could do is, if you choose, uh, you could even choose the minimum Aurora capacity that's there, and also the maximum that it scale onto. A different setting is available for timing out and rolling back. So in case if you would want to ensure that uh, the cluster capacity changes without a scaling point, you could either force change the capacity or roll back the change. And also, if the timeout expires, you have different options. If there's also an option where when your database is idle and there's no interaction happening with your database at all for a while, if when the cluster is idle, you could even scale down to 0 so that you're actually not running the cluster at the given point of time. Whenever creating RDS or any of the servers, you would have to select a VPC. So we'll go with the default. You can specify the different database names. So demo. You can even, again, you can have a encryption enabled by a KMS key that's there, and also you can set up the retention period for your backups. And once you create, since this is a uh, auto-generated credential, you could even view the uh, password that's been generated, and you can copy it so that you can change it when you're logging in for the first time. So once the Aurora Serverless DB is created, you can even view the details, and also so you can see that the info is available. The current capacity is 8 units, and the VPC and endpoint details are available for connectivity. If you would like to change any configuration, you could view all the configurations that's enabled when we created the database, or if you would wish to change it, you could head to modify and change the details here. So since the data API is not enabled, you could not use the HTTP endpoint and query all the DynamoDB and perform DynamoDB and perform Aurora queries. So you would have to enable data API, and once you hit on continue, it'll ask you if you would want to do it at the next maintenance window or immediately. So you could go with immediate, and so to perform different queries, you could head to the query editor, where you can select which database that you would want to connect into. And so this was a new database credential that we just created, and connect to database. So once you connect to the database, you can see a query editor that's available, and this uses data API to perform any of the API calls to Aurora, and it'll return the result as it's being processed. So once I just did a schema star, select star from schema, it returned all these details. And similarly, if you would want to create a new table, so say create table, you could add the SQL statement here and run. So based on the access that is available, you could perform all the MySQL statement executions from the query editor that's available on Aurora console, on RDS console. So that's about Aurora and all the serverless based database offerings from AWS. So that's about it from this session. Thank you everybody for watching it. And if you would like to wish to connect with me, these are my social media handles.